Well, good morning, everyone. I think that all the people who is connected online can see the presentation and hear us. So if there's any problem, just put something in the chat. We are checking with our own connection as well. So thanks for coming to this Info Day presentation of our project, Co-UDlabs. I am Jose Anta, the coordinator of this project. And I would like to thank, first of all, to Fundación Galicia Europa for providing us this nice place here in Brussels to accommodate this meeting. So in this opening, we will have here Ana Ramos from Fundación Galicia Europa, and also to Elena Carbarino from the REA, from the Commission. She's our project advisor, so thanks for being here. And then I will pass the mic to Ana for this present opening.
Thank you very much, Jose. Thank you. Hello, everyone. Good morning, and welcome to our premises in Brussels. Fundación Galicia Europa is the representation of the Galician government to the European Union. We are here trying to bring closer Galicia to Europe, and of course we are clearly committed to European partnerships, and it's really, we are delighted to host this event today. With the leadership of the University of A Coruña. It's really a pleasure for us. So thank you for counting with Galicia to host the event. The Galician regional government is especially committed to establishing European synergies in areas like science and development, and in those when they are at the service of one of the main challenges we face today, which is the preservation of the environment, being the efficient use of such an important limited resource as water key. From the environmental point of view, let me tell you that the report recently published by the European Commission about advancing on 2030 zero pollution targets shows that Galicia is the second Spanish region with the best progress on pollution from urban wastewater. In the last 12 years on record, between 2018 and 2020, pollution has been reduced in Galicia by more than 30%. To 6 points now below the European average still. Regarding bathing water quality, the pollution level in 2022 in Galicia was more than 9% below the European Union limit. This is a reduction of more than 5% since 2018. From the point of view of research, Galician government has just approved its new RDI plan, increasing by 20% the resources dedicated to this area, going to 1.3 billion euros. In line with the European agenda, this plan will prioritize high-impact initiatives such as biotechnology, deep tech, and clean technologies. The aim is to attract and retain the best research talent and to ensure that the results of their work reach society with a positive impact on the economic development of Galicia and the quality of life of the population. This strategy is the result of a dialogue with all the RDIA Galician ecosystem. It should be noted that the number of workers dedicated to RDI in our region continues to grow. There are currently around 14,000 people. This responds to the Galician government's vocation to consolidate Galicia as a pole of reference in research and innovation at European and global level. I do not want to dwell on this because the interesting thing today is to hear the conclusion of your project. Let's listen to the expert. So I just want to thank you again for choosing Fundación Galicia Europa, our facilities for this event today. I would like to finish saying thank you to FEUGA, the foundation that brings together businesses and universities in Galicia, for the synergies we maintain together with the Fundación Galicia Europa that allow us to host initiatives such as this one here in Brussels. Thank you so much, and I hope you have today a fruitful day. Let me congratulate you all on your achievements and advance of 4 years or 5 years of the project work already. Thank you very much.
Thanks. Thanks, Anna. So now is the time for Elena.
Okay. So thank you very much, and I'm really happy to be here. Thank you, Jose. Thank you, Anna. And as Jose said, I am your project advisor, so from the Research Executive Agency of the European Commission, and it has been really interesting following this project and to see the development. So my unit is the unit dealing with the research infrastructure. So our goal really is to empower Europe through the world-class, accessible, and really fit-to-purpose research infrastructure. This project, 4 years, and starting in COVID time, so in 2021, everyone was mentioning this before, so also with all the difficulties to put in place transnational access with that. The call was the Horizon 2020, and it was one in Freya, so putting together basically transnational access, joint research activities and network activities. And I was really interested to see facilities put together for the urban drainage systems, that we can call them critical infrastructure, that we know that provide flood risk reduction, sanitation, and also environmental protection. These infrastructure are at risk. They are really dealing with flooding and all the things related also to the adaptation to climate change. What I would like to mention is that the transnational access. So when I was looking the project there, they had really a variety of topic on that were going, of course, so dealing with the sewer, so looking the monitoring flow and quality technologies or infiltration system. Then there was in Deltares the part on air pocket, and but also the parts on sensing, acoustic sensing, that were all interesting. But not also this. There were projects on green roof, green infrastructure, nature-based solution, other project going through pollutants, so looking, the permeable pavement clogging and the release of pollutant, and going also through the littering transport in urban areas, including macroplastic and microplastic. So really a variety of topic, together with the joint research activities that were more focused on smart sensing and also evaluating basically the deterioration of assets. So the project was also able to go through basically studying a sustainability strategy for the project itself, and also looking so that this long-term perspective, and producing a roadmap for the role of research in infrastructure transition go to innovation. So if we look the impact required by the infra, and also to have basically foster innovation, having also facilitate evidence-based science to policy, and having societal benefit. So I think that this project was really successful. And for science to policy, what I've seen quite relevant is the input, and we have digital environment here also today. So for the urban wastewater treatment, the float directive, but not only, because there is also all the sustainable urban drainage that when I was in the JFT, we were putting in the sustainable and green public procurement. So this is really a nature-based solution, quite relevant. And also, Anna mentioned the zero pollution action plan and the strategy for plastic. So I think there are plenty of information, and I'm really happy to be here today to listen to the final result. Thank you.
Okay, thanks, Elena, for your really good summary of what we're trying to do during these last 4 years of the project. So now I can come back and start or comment which is the agenda for today. After this institutional opening, I will take the word and try to summarize some of the achievements that we obtained during these 4 years of project that ends in 40 days. So this is the first point. And then after this small presentation or short presentation, we have a roundtable in which we will try to highlight some aspects of Co-UDlabs in translating the science to policy and to practice. We have 3 speakers here from the DG of Environment. We have also some internal speakers of the project. We will chat about CSO policy, the urban wastewater treatment recast, and how to translate the transnational access program to the waste, to the operators, to the water utilities, with some examples. And we will have some time also to have a fruitful discussion about this. And in the last part of this info day, we will try to bring on the table some aspects about the future, which is the legacy of Co-UDlabs. What are our short and mid-term next steps in order to consolidate or try to consolidate this research infrastructure network that we built in the last 4 years. So we hope that you enjoy this session. Please be part of the discussion as well. Then we have a networking corner with a small lounge here for the people who's in Brussels. So thanks all to attend here, especially to some of our transnational Azure users that came here and to see this or to attend to this meeting. And I think that for this presentation, it's all from our side. We have here the list of attendees. We will pass these 2 pages. If you can sign the attendance, is okay. And also, I would like to mention that this info day is being recorded, and we will update the slides and also the content to our YouTube channel. So thanks again, and we can start with the introduction of Co-UDlabs. So I can start. I don't know if you want to stay here or you can.
Yeah, you could.
Good. Okay, so I will start with this introduction, and the first point of this introduction or this summary of our achievements is related with why we think that Co-UDlabs was a good proposal for this Horizon 2020 Infraya call for starting communities. So as most of us are working on the urban drainage systems, and as Elena mentioned, urban drainage systems are critical infrastructure that conveying store water and wastewater to treatment facilities. They deal with floodings, with health risk, with pollution issues. But we have several challenges due to the urbanization and climate change that add more vulnerability and risk for flooding or to the aquatic pollution. Our assets, our pipes, our system are being deteriorated and aging, and huge investments are needed for its rehabilitation and replacement. We are working on complex and harsh environments, which makes it difficult to monitor and to control or manage these systems. And using traditional approach is something that is unaffordable. Nowadays, we are moving to these natural-based solutions like sustainable urban drainage systems. So in this context, we have several opportunities like water digitalization, the IoT devices, the low-cost sensor, the imaging techniques. We were working on these opportunities in the project. We have also new modeling approaches. But one thing that is a bit different from other approaches or other projects in the field of urban drainage system, it's the role of research infrastructure. Because our urban drainage community is not organized around a consolidated ecosystem of research infrastructure. There are other communities like this ENRI Hub, for instance, which is a consolidated community with several research infrastructure in some fields of the Earth system, like atmosphere or soils, or the biota, or the maritime waters. So, but this is missing for our community, for urban drainage system. And it's a pity because in our system or in our ecosystem, the water utilities are traditionally cautious innovation adopters because they often require or demand solutions and methods that are close to the real application. They don't want to test new things if they are not have a large high TRL or they are robust because we have complex systems. So to facilitate this innovation and this transition to these new novel methods and technologies, research infrastructures can help. We think that they can help in spreading more efficiently and safely these new methods and solutions using large living labs or before it is a full-scale implementation in large living labs or urban systems. And also these technologies take part of this hybrid gray and green infrastructure concept that is promoted by Water Europe in its scientific and research innovation agenda. So we have to deal with aging systems, with gray infrastructure, and we are adopting new green solutions. But both have to live together, and we have to complement. We need to work with smart solutions, with data, with new concepts, with new methods. And we think that research infrastructure can help to implement this new hybrid gray and green infrastructure approach. So this is the context. So what is Co-UDlabs? Co-UDlabs is an Infraya starting community from the Horizon 2020 call. It was the last call of Infraya in this Horizon 2020 program. And we aim to integrate research and innovation in the field of urban drainage system by creating a research infrastructure network. So our consortium has 9 partners of 7 European countries. 7 partners are providing facilities for the transnational access, but we have more partners dealing with the stakeholder engagement, with the community engagement, and so on. This is a project of 4 years of about 5 million euros. And as a typical or conventional Infraya project, as Elena mentioned before, we have like 3 pillars or 3 main goals, which are related with fostering the culture of cooperation through the networking activities. So we have some work packets related with these networking activities to develop a more inclusive and open research. The idea is to come together to solve practical problems, to share ideas, to share problems, and look for new solutions. And this is promoted by the networking activities. We also facilitate the exchange and perform a collaborative research in our facilities through the Transnational Access Program that I will chat at the end of this presentation. And then we also were dealing with the strength and the improve of the services of our research infrastructure network. And this is something that we've done with the different joint research activities. So our networking activities, we have 4 work packages or 5 work packages related with that. And the overall idea is try to establish and learn and start to consolidate this network, involving not just academia, involving end users and practitioners. So we have some activities related with the sectoral integration. We have a stakeholder database with more than 150 stakeholders that read or receive our newsletter and our work. They are updated with our different activities. In the Transnational Access Project, we achieve or we have a community of more than 200 participants. So, and this is, we are really happy about this because we start from the scratch. And now we have this small community that is growing. And also, we started during the COVID lockdown. So it was something that we have to deal with, how to provide this face-to-face or in-person access with the limitation of travels and so on. This is something that passed and hopefully went, I think, that really well. But it was another challenge of our project. So in order to consolidate the network, we are pushing, or we have pushed the creation of the first working group on large research infrastructure in the Joint Committee of Urban Drainage of the IHR and the IWA, this UDrain working group that has been established after the last ICUD Congress in Delft. Now we have a small roadmap. We plan to release an atlas of research infrastructures in urban drainage, a worldwide atlas, with not just with the facilities of Co-UDlabs. This is a collaborative effort. It's open to all the researchers and open to all the industry that can provide access to their facilities. And we will launch a webinar probably before the summer, or otherwise in the UDN Congress in Innsbruck. We will have our first meeting to establish this working group. We will comment on that in the last part, in the legacy section, in the next steps or in the future of Co-UDlabs. We were also dealing with science to policy and science to practical actions. We will present this CSO policy in brief. It's our first policy in brief. From the project, we will try to prepare more. This is not compulsory for our actions, but we think that is really important. Try to condense all the experience or the task that we perform and try to bring them to the policymakers. Then we started to work in the harmonization and the capacity building, how to start to work with standardization of our data, of our sensor within the consortium. We also push a lot of several or different training activities, dissemination activities that has been essential to outreach a large community or large audience. We focus on the early stage researchers with 4 workshops and 1 PhD course. We also organize webinars online for the academia, some workshops for the practitioners. Here I would like to suggest the last webinar that we organized. It was led by AKT from Chef from Germany. Sorry, before I didn't went to the different partners. I can comment afterwards in the TA. which is really nice because it's a good summary of all the work that we perform in the different joint research activities. It's available in our YouTube channel, and tomorrow will be on the news of our website. And also we deal with some face-to-face training for practitioners at INSA Lyon. Our partners develop some courses on uncertainty analysis, uncertainty analysis for data from sensor, data validation, and so on. And we in A Coruña, we also organize a small course of metrology in our DNA facilities. And besides that, we also work in the scientific dissemination. We have work with the publication of the results in scientific journals, in data sets, in science events for the citizens. All this information is available or will be available in our website and in our Zenodo community. I don't want to go to the KPIs, to the details, but there's a huge number of works that has been produced and some others that are on track or on course. Some of them are related with our joint research activities that are dealing with the smart sensing and monitoring in urban drainage. We are looking for new sensors, new methods for data validation, new methods for uncertainty analysis, new methods for the analysis of distributed data. Then we also deal with the deterioration of assets, mainly with buried pipes, with like a holistic approach that I will show later or soon. And then the last joint research activity was related with the improvement of the resilience and the sustainability of our system. We realized that we need the standards or harmonized methods. Don't think in a standard like in a regulation. We need harmonized methods to test our assets for floodings, for pollution control, to analyze the pollution processes, the transport or pollutants or plastics or wherever, or the clogging of permeable pavements. Because we are working in different places, we have 7 partners with facilities, but around Europe and around the world, people is doing this analysis without a unified point of view. So we have to deal, or we have work on this direction as well. So the first joint research activity is this smart sensing and monitoring in urban drainage. So we identify and evaluate new sensors and technologies from, let's say, a mid to mature level of TRL for hydrology and hydraulics and pollution. We have released a deliverable with the tests that we perform about this, and we will plan to also release some data sets about this work. We were also dealing with the definition and the new methods and tools to improve evidence base for reliable and validated urban drainage monitoring data. From INSA Lyon, they lead the creation of this urban drainage metrology toolbox, which is an open source platform to calibrate, to analyze the uncertainty, to do data validation of our sensors, our sensor data, because we need reliable data to take decisions. Or to make decisions. And then we were also dealing with new methods to analyze and interpret distributed data from sustainable urban drainage systems. But in our case, we focus in the combined sewer overflows, because we will deal with all these huge amounts of number of CSO spills or spill points or spill infrastructures in Europe. And we need to analyze this data. So we here highlight some methods to deal with this. So in the second joint research activities that was led by Sheffield University in collaboration with AKT, in the first one, most of the partners take part in the joint research activity number 1 in the smart sensing. In the second one, this was led by Sheffield University, with mainly with the collaboration of AKT and EABAG and Deltares, but I would say that these are more or less the main partners. So we were working in new tools to assess inspection, taking images from CCTV cameras and deep learning methods to identify the different cracks and problems in the pipes. Then this is linked with the development of a risk defect model. Once we have this information, we work also in the lab to determine and understanding the mechanisms of failures with revising analytical models or empirical models, also performing a catalog of failures, testing these failures in the lab with novel technologies. And by the end of this timeline, all this knowledge was included or in the numerical model, how to interpret these failures in terms of hydraulic or pollution problems in our networks. So this is the pipeline of this joint research activity. And then in the last one, in this improving our resilience and sustainability, as I mentioned before, we work, I would say not mainly, but one of the key points, this joint research activity was led by my university, by the University of A Coruña, with the collaboration of again, most of the partners that are working in the transnational access. So we try to develop a consensus of measurement of hydraulics and water quality performance through our facilities, or using our facilities, for instance, to evaluate new methods to determine digital terrain models, how to evaluate or how to use imaging techniques to detect velocities or track pollution, transport, or using new low-cost sensors like temperature sensors to track processes in sewer processes, new methods for clogging of permeable pavements, aging of green infrastructures, plastic litter transport, a lot of different things that, as I mentioned before, if you have time or if you are interested, just ask to us, have a look to the webinar, and then we will comment another sources of information in the legacy. So we were working as well in quantifying the resilience, most related with floodings. Here, Sheffield has a prominent work on how to evaluate the energy losses or analyze pollution transport loads in dual drainage system interaction between surface flow and in-pipe flow. And then with the work of Aalborg University and INSA, we were working as well in improving the sustainability in some selected SAT solutions, like a stormwater ponds or soil filter or technosoils for bioretention areas, for instance. And this is what we did in the joint research activity, but maybe the most different characteristic of this project is the transnational access. It's the core of this European Infraia project, making our large research infrastructures available to the public, to the people which is not in the consortium, to the people that can attend for free. To our facilities, we pay. Okay, we or the commission, our project pays for the travels, for the allowance, for the accommodation, but also for the work in the lab, for training the people, for developing the test. Tests that we work with. Let's say we had two kinds of access. Most of them are in-person access. We are working in projects of 2 or 3 months duration. We have to develop prior to the test. We have to build or rebuild or readapt our models. Then the people is coming. Then they are doing the test. They have to collect the data. Then we have to follow up all the data sets that they are gathering. So this is a long-term process, which is it's really nice and really challenging as well. So and again, as Elena mentioned, we work in the whole urban drainage system. We are not we focus in several aspects. We were working in urban flooding, in runoff pollution, in sewer processes. We evaluate the system performance, the assets deterioration. We work also with SaaS solutions, with digital methods, with digital water solutions. And all these things came together in our network of 7 research infrastructures, 17 facilities in A Coruña, Sheffield University, in León, EABAC in Switzerland, AKT in Germany, or Deltares Institution in the Netherlands, and also Aalborg University in Denmark. So this is this large network of 17 facilities, and to provide the access, before telling that, as I mentioned, we have here, you can see all the facilities that we have, and we try to represent here the ambition or the field of work of the different facilities that, as I mentioned before, we cover the whole urban drainage system. We don't deal with wastewater treatment plants, but from the rainfall till the entrance to the wastewater treatment plant, most of the things that you can analyze can be done in our facilities, in the lab or in the field, because we have also field facilities in the projects in EABAC or in Switzerland, in France, and also in Denmark. So the call, to prepare the call, we start from scratch. So we have to build all the pipeline. We have to provide some guidelines for the access. We have to promote the calls. At the beginning, we plan 2 calls. But at the end, we move to 3 small calls, but to 3 calls with a small one, just to provide or to fulfill all the requirements of the grant agreement. I will say that we are above the requirements of our proposals. But to do that, we organize some webinars online. We also organize a webinar in person in Novatech in Lyon, in which we try to engage the community and to facilitate this exchange with the academia and the operators and the water utilities and the administrations. We also organized 2 hackathons in which we offer our facilities. The people came with ideas, and we try to make some kind of match between the different things. The prize of this hackathon was a field trip to the facility that's of the proposal. This was made before the proposal submission. Once all the proposals were submitted to an external evaluation panel, they decide about which are the good ones for our program. And as I mentioned, we started with the first call in 2021. The call finished in January 22. And we select 13 projects for the first call. These projects have finished all of them, all the information of the accesses, and it's released in one deliverable of the project with a summary of the different projects. And now we are dealing with the end of the second call and the third call, in which we have 18 projects. The last projects are about to finish because we have 40 days to the project end. So this week, some colleagues of A Coruña are finishing with the Coventry and the Oviedo team, the things, but everything will be ready for the reporting and for the end of the project. But we are, as we want to reach more people and to have this opportunity, we expand a little bit the call deadlines or the project deadlines to accommodate more people. So at the end, this is a nice summary, I think, of what we achieved in this call or in this transnational access program. We got 41 proposals, 31 was awarded. We have about 200 users from 26 countries. We involve more than 100 institutions from academia and the industry and administrations. I think that we have a good number of non-academia participation, about 30%, I guess, 33%, which is good. I think that is something that in other research infrastructures or in other projects similar to this one, the figures are a little bit lower. So this is a reflection or a message that in our community we need to engage with the operators, with the policymakers, and so on. And we try to do our best, and I think that we have a good figure about this. Yeah, more or less, this is the summary. A lot of efforts to organize this transnational access call, and this is something that will be continued, because as I mentioned before, even if the project ends in 40 days, we will continue working with our TA users, because they have some time to release the data sets that is in the grant agreement, so we will collaborate with them. Also to publish the results. Some of the results of the first call are already available, but some of the results of the second call will be available after the life of the project. Today, we will also like to present our final media kit with a summary of everything or the highlights. So words of the forward. 4 years ago, we started to work in integrating innovation and research activities in the field of urban drainage system through this research infrastructure network. Through this collaborative effort, our network supports the urban drainage research community, water infrastructure operators and regulators and local administrations, dealing not just with the technicalities, dealing also with this networking creation. And as I just mentioned, this significant progress made in this short time period, we believe that many results are yet to come, because sometimes the research timeline funding do not coincide with the research timelines typically do not coincide with the funding periods. And this is something that we know, and we will continue working after 30th of April. So thanks for your attention. Okay, good. So now I think that we can move to the roundtable. I think that from my presentation, I don't know if there are some questions, but maybe we can accommodate for the next section. So I will introduce to Ian Naismith from AKT. He will take care of the moderation of the roundtable. So the floor is yours, Ian.
Thanks very much. I'd like to invite our three panelists up. So that's Simon, Trudy, and Thomas. So what this session is about is how do we translate science into policy and into practice, but also for us, how do we translate policy back into doing more science, which I think is the final part of the presentation of the morning today. So what we've done here is to pull together, we've got 3 short presentations for you, which set the scene for how does science relate to policy and practice. And what we've done is that, first of all, we've got Professor Simon Tate from Sheffield University, one of the partners in the project. And he's going to be talking about some policy output that we had from our joint research activities on combined sewer overflows, CSOs, or storm sewer overflows, as they're being called in some countries now. And this is a pretty fundamental issue that we did a lot of work on, and is an example of how we have taken some research and we're now able to perhaps put forward the results of that can be used by policymakers. But then when we look at policy, now policy comes at so many different levels. And obviously here we are in Brussels, the European Union, particularly with its directives, is setting the policy. But that then feeds down to the national level. Within the countries, it feeds down into the regional level, for example, across the Länder in Germany. And then it feeds down into what is happening at the level of the municipality. And it's when we get down to the municipality level, that's what a lot of this is all about. It is about urban drainage. It is about urban wastewater. It is delivered in a variety of ways across Europe, but primarily at the municipality level. And it's taking our science down to that. And in a way in which we can do that, and we therefore, is that we need to look ahead. And so Trudy is going to talk a little bit about the new Urban Waste Water Treatment Directive. And we were discussing over the coffee. That directive goes out till 2045, final implementation, 20 years of different organisations down to some quite small community levels now that are going to be having to implement this policy. And there is an opportunity for those of us who are doing the research to be contributing and working with them. But taking it beyond that, there's so many different stakeholders that are involved in all these activities. And it is down to manufacturers. We've done a lot of work on sensors. We've done a lot of work here on investigation methods. We've done a lot of work on rehabilitation methods. It's the how do you create the new and how do you maintain what you've got. So it's manufacturers in all the countries across Europe and beyond who are providing products. Those products have to be distributed. We've got suppliers involved. And then there are the contractors. There are the consultants which are deciding where they're all going to be installed and used. But then actually at the end of the day, it's the end users are the municipalities, or people who own these networks. They're trying to apply policy, and at the same time, they're trying to find solutions. So Thomas is talking about one of our transnational access projects at the end. It's actually mentioned in the back of the book here. It's the AIR project, and there's a picture of a happy university researcher from the UK with his instrument that we put through its paces at the facility in Spaghetti in Germany. But with the AIR project, that really did bring together a lot of different people with solutions, and we compared those solutions. And the commissioning body for that project, because with all of our transnational access projects, there's an organisation that led it. This was the sort of wastewater research organisation from the Netherlands, RIANET. They wanted to know how do all the different instruments work. And they brought together a group of their members, and we brought in some British and other sewer network owners who were interested in finding a solution to how could they inspect pressurized sewers, a very particular issue. And we put them all together. And as a result of that, we then ended up with some recommendations about instruments that could be used. And RIANET has taken our project from this research and they used it as a pilot. And now they have their municipalities, some of their members are putting some of these instruments that we trialed through pressure sewers in their own cities. And there will be a further research report that will come from RIANET built upon what was done here. At the end of the day, we are research facilities, and through this Co-UDlabs project, we have come together and we have found new ways of working together in order to deliver science for policy and practice. So, following that introduction, I'll hand over to Simon to just talk a little bit about how, on just one area, combined sewer overflows, Co-UDlabs has taken this issue forward.
Okay, thank you very much, Ian. My name's Simon Tate from Sheffield University. So I'll be talking about some of the ideas we've developed in Co-UDlabs, and they've been developed by a number of partners and a number of people. It's our appreciation of, let's say, where the Urban Wastewater Treatment Directive recast is, but from the view of scientists trying to help implementation. So I think we'll have some comments about the directive.
Sure.
And maybe try and suggest some of the analysis we've done with utilities, looking forward to the directive itself, and then maybe pick up maybe some issues that we think require some further work. We're all mad scientists here, but we like to welcome the recast of the Urban Wastewater Treatment Directive. It's got an expansion of wastewater collection systems, particularly for small urban areas, and we've seen that they are key sources of pollution into the environment. There was also an emphasis on condition, which I think is often neglected in the collection systems. There was more focus on storm sewer overflows, with a focus on environmental harm and public health, which I think again is to be welcomed. And probably what we saw as maybe the more innovative type impact would be these integrated wastewater management plans, and particularly at a local level. And we think that will really drive improvements. Things that did confuse us slightly is, although we talk about environmental harm and public health, there seems to be a big focus on emissions rather than impact. There was an indicative annual pollution load limit. The good thing was there was supposed to be a demonstration that the local urban wastewater management plans are effective. And we think in our sort of new digital age, demonstration to the public, people to pay for the improvements is really important. And there was the repurposing of the obligation to make environmental data public. And we think making data public is a very dynamic and interesting issue, and it's one that we think will drive change. So let's talk about some of the analysis we did. And most of this was led by my colleague Alma Sellert at Sheffield. So we thought the scale of this issue, particularly storm overflows, is poorly quantified. So a questionnaire was sent out to water utilities throughout the EU. And the sort of 4 basic messages are at the top here. If you looked at overflows currently and you asked water utilities, did they check the compliance of their CSOs regularly? 90% said no. So compliance checks at the moment are very, very low. If we looked at the number of CSO structures that were monitored, so this one here, the turquoise blue line showed that over 50% weren't monitored. What happens if a spill occurs, or what's seen as an illegal spill? There would be an investigation for 60% of these spills, and these were the ones that were observed. But the investigation didn't lead to any action. And when we talked to people as why action wasn't taken, the most common reason was that it was very difficult to demonstrate compliance. So you had a CSO that might have an issue, or there was good evidence that it had an issue, but to actually show whether it complied with local regulation was extremely difficult. And when we looked at CSOs being regulated, most were a mixture of emissions and impact. So a mixture between impact and emissions. So we took this analysis and thought about it, and it was clear to us that certainly for storm sewer overflows, measuring emissions and impacts were difficult. They were very intermittent, very difficult to observe. And one of the things we maybe criticise the recast directive is that the number of pollutants water utilities have to monitor and measure is exponential. It just keeps growing. So they're having difficulties at the moment looking at water quality, but the range of pollutants that they need to observe just gets larger and larger. We saw a conceptual mismatch between the Water Framework Directive and the recast Urban Wastewater Treatment Directive. One seemed to be very impact-based, looking at ecological status. The other one seemed to be very emissions-based. And we think that's a key sort of conceptual mismatch that needs to be thought about. One good thing about the recast directive is it accepted historical national design standards. So it's very pragmatic in that view, is that different networks. So I think the photograph at the top is a network in Germany. This one's one in the UK. And one thing that we thought wasn't really focused on was that what happens if the network's not working? So the picture at the bottom right there is a storm sewer overflow in the UK that's operating with no rain. So an easy compliance check, that one, but it's a view that probably evidence from the UK is about 30% of overflows are caused not by incapacity in the system, but the system's not working. It's poorly maintained, there's a blockage, something is not operationally correct with the system itself. The other issues that we looked at were, we looked at the role of public data. Now, the recast directive is very pragmatic. It says you can use monitoring or modelled information. In the UK, we're not so pragmatic. Everything has to be monitored because nobody trusts the water utility. So the sort of top picture there, the sort of brown dots, is some data from the UK. So at the moment, we monitor hydraulically all our storm sewer overflows. It's taken 10 years to get there, but all our 15,000 SSOs are monitored, and the public can see this data now in real time. And that's driven, I would argue, big public debate in the UK, a political consensus, and it's led to probably a quadrupling of investment in storm sewer overflows for the next 5 years compared to the previous 5 years. And that, I would argue, has come from data visibility. Nothing else. Politicians didn't think it was a good idea. It was so visible that they took action. So I think one thing to think about the recast Urban Waste Water Treatment Directive is I can understand the pragmatism of going for a modelled and a monitored approach, but is that really going to drive change? Or is it going to be acceptable to the public? Because the public now are much more used to having data-driven devices. Your car gets live traffic feeds, you monitor your energy use. Don't you want to see your local SSO performance as well? So I think data is going to drive things. And the last comment I want to make in the slide is this is a network in Switzerland. It's got 8 SSOs in it. Once you start putting defects in this network, 3 of the SSOs behave in a very, very different way. 2 of them, the volume of the spills goes up by almost 200%. 1, the volume of the spill goes down by 100%. So as you start to put defects into your network, let's say intermittent defects, certain SSOs behave in a very different way from the way that they were modelled. I'm not saying this is a representative network, but certainly the data that we have from the UK, about 30% of the spills weren't modelled. They occurred for other reasons. And this was evidence of this. So we've started to take together the evidence that we've gathered from water utilities, from our modelling, from an analysis of the evidence out there. And as Jose said, we've started to put a sort of policy brief together, which will look at things like, do you balance emissions or impact? What's the importance of monitoring against modelling? And how we can actually help with innovation to try and enable the recast Urban Wastewater Treatment Directive to be delivered in a pragmatic and cost-effective way. Because everything you spend on monitoring, you probably won't spend on making your system better or doing better things. So there's a limited amount of resource, and it's how you balance that spend over a long time period In the UK, we have a storm overflow discharge reduction plan. 5 years longer than the EU one. It goes to 2050. But these are big investments over a long time. But they're important. And if you get them well with public support, then you make a big impact.
Simon, thanks very much.
Yeah.
Just one point of a question. The policy brief there,
Yes.
is that finished or is that one of our outputs that we're still waiting? Almost. That was a taster. That was a.
So we have to check the typos.
Yeah.
I would say so. It will be released probably in the next week on our website, and I think we can share with all the attendees as well.
Yeah, I think we're comfortable with the policy recommendations. It's just getting the language of it.
And I think what we'll do is we'll have the 3 presentations and then we'll take the discussion and questions after that. So next, I'm delighted to introduce Trudy Higgins, who from the Director General of the Environment here at, and we're not expecting you to defend the position of the CSOs. The CSOs here is just one aspect of it. I think, as I stressed at the beginning, it's that this directive sets a future vision that is going to require an awful lot of effort on many people's parts. So over to you, Trudy.
Yeah. Good afternoon or morning.
Morning.
Good morning.
Hopefully it's still morning.
Yeah, and yeah, pleasure to be here. And what I'll do is probably chicken and egg. Maybe I should have gone first. Who knows?
Yeah.
I'm just the new directive entered into force on the 1st of January this year. There's many components to it, but all I have on my slides really is a focus on the topic of today, which is the drainage aspects and Article 5. But I will give you a brief overview just for some background. There's a lot more information on our website. So for some of you that are older, like myself, I would have been involved in implementing the 1991 directive, which was shorter. On paper, it was quite a simple directive to follow. Requirement for collection systems, requirement for secondary and tertiary treatment and monitoring and reporting. The bad news is that it still hasn't been fully implemented in a number of member states for various reasons. So back in 2019, as the Commission does, it evaluates the legislation in place. And from that, we realised the carrot being a lot of investment from cohesion funding and elsewhere at EU level worked, but also the stick still was required a lot. So there's still, to this day, many infringement cases, both on stormwater overflows, levels of treatment in individual systems and others. We did a lot of modelling with the JRC back for the evaluation, and that work continues to this day. The work with the JRC, which is part of the Commission. They developed many models, but what we did was we developed a European model based on the data reported from member states through the directive to simulate at EU level, but that's what we needed to do for the purpose of the evaluation, what the impacts of implementation of the current directive were, and we could show fairly well that it did reduce pollution. So in the old days, it was just BOD, phosphorus and nitrogen. They were the targeted parameters then, and now it's still a technology free directive. So we tell them what we want, but we don't specify how to get there. And true, whether it was protecting of bathing waters or drinking water or others, we could monetize those benefits being greater than the substantial costs. And again, through that evaluation, we'd still issue remaining pollution is a catch-all for the pollution that wasn't captured. It could have been whether it was through non-compliance or it was never a focus. We continue, again, linking in with the Water Framework Directive, that both stormwater overflows and treatment plants are a significant pressure, and eutrophication being a typical one. The directive then evaluation came at the early days of the European Green Deal, which is maybe dead now, I don't know. But so, there's a lot of other new innovations there on energy use and sludge management, as we heard already, better governance, transparency reporting, and a lot of legislation come after the Urban Waste Water Treatment Directive and has continued to evolve. So that was where we needed to pick up from. So through the, so this is the short summary of the whole directive in a page, as best as we could get it. I'll just highlight some of the more relevant pieces. The old directive, the limit was 2,000 population equivalent, which is still 20,000 agglomeration, but we were missing a lot of the issues. And again, through looking at river basin management plans, we could see that actually a lot of the pollution sources were probably now the smaller urban areas that hadn't been really focused on. We could see there was a lot of issues where individual systems were in place, these small treatment plants. So we needed to get stricter on that. Secondary treatment, we didn't change in terms of the limits, but we did make a blanket requirement for the first time. There was lots of get out of jail clauses on it. And with tertiary treatment, so whether it was nitrogen levels or phosphorus levels, we did tighten them up. What I'd say is we did a lot of modelling with JRC. We had a lot of data. We would have preferred, as the Commission, to come up with something a bit more ambitious in some things, including the limits. But that's a negotiation that you go through with the Council and with the Parliament. So what you see is, in sometimes maybe what we hoped for, but it's better than not. And why secondary and tertiary treatment is important is because when we look going forward at the stormwater overflows, we need to keep that in mind. Those limits will apply one way or another. The integrated plans, which I'll go into in a bit more detail. First time that we have brought in a fourth level of treatment, quaternary treatment, more or less totally based on what they've done in Switzerland for a number of years, where we're trying to remove 80% of micropollutants with indicator substances. Energy neutrality at national level, so the bigger treatment plants, there's opportunities for energy efficiency and development of renewable energies, and then bringing the legislation up to date, access sanitation, access justice, information. We brought in surveillance of health parameters, so a requirement to monitor for AMR, but also systems in place to monitor for infectious diseases, whether it's COVID-19 or influenza, whatever. And water reuse, there is a regulation there, but maybe trying to open it up more. And a risk-based approach, which is also important to look at, because for those smaller agglomerations or those smaller plants that are sub-threshold, they could still fall out under a risk-based approach, which is another component which probably links a bit better with the Water Framework Directive. So it's a bit of a catch-all there that we got in. And yeah, so I won't spend too long going into the detail of the directive. So Article 5 is the main article. So by the end of 2033, those large agglomerations, which are over 100,000 population equivalents, need to have a plan in place. And then on a 6-year cycle, the agglomerations, 10,000 population equivalent and above, first of all, the member states need to identify which ones should be on a list. And then they have more time then to actually develop the plans. And again, everything is reviewed on a 6-year cycle. The other part you'll see under Article 5 is a mention of implementing acts, which is secondary legislation, so it hasn't been drafted yet, where we get into more detail on methodologies for this magic 2% threshold that sometimes perplexes even me. And also the format of the plans going forward, and also what measures the member states need to, or whoever's doing the plan needs to consider. So it's just to give a harmonisation to some of those requirements to make it maybe easier for people to follow it. Annex 5 is important as well because that gets into more detail on the content of the plans. the focus is really, I suppose the main, what we saw through the modelling the JRC did for the evaluation, but also they did modelling for the purposes of this impact assessment. So we looked at lots of different policy options and had to come up with something that we thought was reasonable. Was that when you look at large urban areas, there are huge point sources, whether it's treatment plants or stormwater overflows or even urban runoff. So they need to be tackled. So that's why it's not outcome based. It's more, it's a big problem. And also there's all of these multi benefits from integrated plans anyway. It's not just about pollution anyway. So trying to, think about the flooding issues we talked about, the better stormwater management. And bringing in the planners, the landscape architects, all of those people that need to come in together to give something that's a bit more sensible. So ideally, yeah, you want to have a plan in place for every urban area, but we have to start big and see how that goes. And the deadline for the pollution reduction objective is 2039, not that far away. And then for those listed agglomerations is 2045. Agglomerations below 10,000 can also be included. So again, under, I think it's Article 18, where we talk about risk-based approach. If there's a threat to the environment, then you also need to do a plan for the smaller areas. So that's a bit of a catch-all, but that's the easiest way we could do it for this type of legislation. And as you mentioned, we're requiring a lot of analysis of drainage areas, trying to make best use of modelling and data to reach this 2% target, and also, as we put it, a progressive reduction in macroplastics, but not so specific. So the member states are going to have to report every year what they've, once they're up and running on the measures they put in place. We're going to give them through this secondary legislation quite a bit of guidance, I suppose, in a way, on what the measures, what is the definition of a measure, and then what we think it should do. And then the members through these plans, those who are doing it, whether it's the wastewater operator, the network operator, the municipality, whoever does the plan in that local area, they'll need to demonstrate that they went preventative first. They looked at the optimization of this infrastructure they have, and that includes obviously renewals and, upgrades rather than building any new infrastructure. And then, there are some good examples across member states of these plans, and it doesn't work unless it's very clear, very process led, and very clear who does what when and how they're going to deliver it. So that's the very short run through of the text for you to get us started, I think.
Thanks very much. I mean, that does really quite help us to visualize a future, but also thanks for being sort of explaining the pragmatism that goes into the directives, and where we're going with that. And then if we pass on to Thomas Broodman from IKT. Thomas has been involved in running 4 of the transnational access projects that we undertook. And we've just picked out this one, the AIR project, on which was instruments for monitoring the condition of pressure pipe, as an example of how we bring everybody together through this research to address particular problem issues. So if I think we go forward one slide.
Yeah, okay, thank you very much, Ian. My name is Thomas from IKT, Institute for Underground Infrastructure, based in Gelsenkirchen in Germany, in the Ruhr area. And we are working on rehabilitation issues and construction and operation with sewer assets mainly, but also we are working on questions on research regarding SATs. We have been involved in Co-UDlabs since the beginning, and we are, already mentioned it, we were running 4 of these transnational access projects. And I'd like to introduce now one of these transnational access projects where really utilities have been involved, but also industry, and also of course some kind of wastewater umbrella organizations. Yeah, my presentation is how to involve utilities and industries, and I'm presenting you the ideas of networking collaboration for research institutes and universities. Next slide, please. Okay, magnetic. Doesn't work. Yeah, takes some time.
Oh.
Time.
It seem to be wanting to go down. Or is it the clicker you've got to use? Oh, there you go.
Okay, here's the next slide. First of all, I'd like to give you an overview which are the main players or main stakeholders in the water sector regarding urban drainage. On the left-hand side, you can see the testing and science. That means the universities and also research institutes. They are developing and testing innovative solutions. They are testing products. They are doing also practical and, of course, basic research. And sometimes they are doing also some consultancy regarding the municipalities, how to implement some new solutions. On the right-hand side, you can see the asset owners and the industry, the water umbrella organizations, and the politics and authorities and national differences. And not mentioned here, maybe also sometimes the citizens, when you have research projects coping with public relation, and you have to involve citizens, for example, for property drainage or for implementing such. In my opinion, we have to make a difference between asset owners, which are sometimes also industry or private water companies like in England. And we have to make a difference between asset owners and industry itself, because the asset owners, these are the ones who have to implement new solutions, who have to cope with products, who have to work with products from industry, who have to, who are responsible for maintenance of assets and for implementing innovative solutions. So that means these asset owners, sometimes industry or sometimes public companies, sometimes private companies like the water companies in Great Britain, or public means, for example, municipalities, and they have to make the world better. And so, in my opinion, these are the main players which should define research, which should, give questions to research institutes where we should work on. On the other side, we have the industry and the manufacturers and suppliers of products and materials for urban drainage. They are also developing innovative products and solutions. That means also maybe the research institutes can support them when they are developing innovative products. And sometimes you can see that here the industry also means that there are service companies for the asset owners, for example, company for sewer cleaning, a company for rehabilitation, and so. So sometimes they're also involved in the process of maintenance and operation with the sewer assets. Then the third group are the water umbrella organizations. These are often organizations which are pooling and representing the interests of the water sector. For example, also pooling the interests of municipalities. And there are international organizations like EWA, IWA, and national, for example, national organizations like Flario in Belgium, RIAMAT in the Netherlands, or for example, also the DWA in Germany. There's sometimes also participation in standardization committees. And then, last but not least, to mention the politics and authorities. Then national differences in laws, regulations, funding research. that's here also with the Co-UDlabs, because the European Union has funded the project, and monitoring. They are also monitoring the compliance with laws. Sometimes authorities who have a look on implementing the laws. On the next slide, please. Yeah, this is an example within Co-UDlabs Transnational Access Project, air assessment of inspection pools for rising mains. At IKT, we built up a test setup made of a pressure pipe, and we simulated there different kind of defects. And then we invited the inspection companies to come to IKT, so they had a chance to test their inspection techniques they offered. And also, University of Sheffield was involved with a new inspection system, not only industry, but also University of Sheffield was involved, and University of Bristol with a new inspection system. So they had to detect with their inspection systems the defects, and at IKT we evaluated these different kind of inspection systems. You can see here on this picture that there every stakeholder, nearly every stakeholder was involved. On the left-hand side, you can see the network owners. This was, for example, the RioNet organization from the Netherlands. This is a water umbrella organization in the Netherlands. They are pooling the interest in the Netherlands regarding research for the municipalities. But also to mention the city of Arnhem on the left-hand side, because as Ian already mentioned that in the city of Arnhem, this inspection system are now tested in situ. So this project is running. It was a following project. It is now really funded, national funded, I think, by RioNet. But also involved some British water companies, Wessex Water, Yorkshire Water, Severn Trent, and United Utilities. These water companies and municipalities were part of this user facility group, which had a chance within Co-UDlabs to get access to IKT test setup, where we build up this special test stand made out of pressure pipes. These network operators, they defined requirements how to inspect the systems and how the defects should look like. On the other side, you can see on the right-hand side, on the top, you can see the private companies, industry, which has been involved in this project. These were the companies Xylem, Rosen, and Aquaman, which were offering their inspection tools, and they sent their staff to IKT to test these inspection systems. On the right-hand side, you can see also, of course, science and testing involved here. That was IKT, also Co-UDlabs offering these facilities within the project. And University of Sheffield with their own system testing there, and also University of Bristol testing their system. Funded by the European Union, so that is the funding body, the political authority which was involved. So you can see here in the middle, there's a kind of circle system. So you have input from the network owners, that means the requirements. And then we have the product realization made by the industry with their new innovative techniques to inspect these pressure pipes. Then you have the testing, analysis, recommendations made by science, made by IKT in this case, and also by other scientists who have been involved. And then the manufacturer should improve their techniques after testing these techniques. And yeah, this should lead to resource management and again to product realization, optimization of their techniques. So there should be a continuous process of improvement of quality. On the last slide, you can see some pictures to give an overview of the project. Here are the different kind of companies which took part in the project. You can see the ultrasonic system of Aqua. They put in our facility. Then you can see some kind of small ball like xylem, which was put in this facility to detect these defects. It is an acoustic system. Also, an ultrasonic system used by University of Bristol, which was tested, and also acoustic system of University of Sheffield. The company of Rosen had also a special device which was put in these pressure pipes. I have to say that it is very difficult for network owners to inspect these pressure pipes, rising mains, compared to the gravity sewers. Gravity sewers you often can inspect with a CCTV, but in this case, for the pressure pipes, you have the problem to inspect them because they are running and they have a lot of pressure, and that means that it's difficult also to inspect them. And so therefore, the network owners, the municipalities, they need different solutions to cope with the problem. The outcome of the project is the information about the performance of the different kinds of systems which were used and their application limits. And the outlook is, it was also a basis for a current pilot study I already mentioned. Behavior in reality, I would say, in the Netherlands. It is made now in the city of Arnhem. If you're interested in details of the project and the outcome in detail, you can find it in the report. It's at the moment, I think, only available in Dutch, but you can also find a short version on the Co-UDlabs webpage in English. But I think, Ian, you are still working on translation for an English one. I don't know.
No, I have finished it, and I have started handing it out to people. So yes, there is a report.
Okay.
Yes, it's available.
Thank you very much.
I was just going to say, Jose, I think we started about 10 minutes late, so is it okay to have 10 minutes of questions?
I think so. Yeah.
There was a bit of a delay due to some technical issues at the start. So I think what I'm just going to ask is the audience, if you have questions or comments you'd like to make for what you've just heard. And if not, next slide, Simon, because you did have some questions.
I have some questions.
All of them.
Not all of them.
Not all of them. Simon, do you want to elaborate on your observations?
I think the first one is this balance between emissions and impact. I appreciate emissions are pragmatic, but I think people are interested in impact. That makes sense. That's how we get that balance to best reflect where we want to be. So,
Do you want to repeat it?
yeah, probably.
Okay.
Okay, yes.
So I think the first question.
Allowing a bit more time for this session.
Yes. I think the first question was to look at this balance between emissions and impact from overflows. I mean, emissions are a very practical way, because one of the things that we did find is that when water utilities or environmental agencies were trying to check compliance, they needed something that was practical. So they could deter. So both the water utility knew it was complying and the environmental agency was aware that there was a compliance issue. And if it was complex or different, then the system didn't work. Your assets didn't improve, even though the water utility wanted to do something, and the environment agency struggled to make sure that the water utility was doing what it should be doing. So it was how do we get this balance between emissions and impact, I think.
Yeah, I'll try and answer it. So what I'd say is the old directive had a little footnote in an annex that led to this, a lot of infringement cases against, I know, Ireland, myself, and the UK, on this rule of thumb that developed: if you had more than 20 spills in a year, you had a problem. But obviously rainfall patterns are different, you've got different geographies, you've got different dilution flows available in receiving water bodies. And it became quite convoluted. I think some of the justifications maybe from regulators as to why they did or didn't put in trunk sewers, or remove stormwater from the system, whatever, to get this down to this magic 20 spills. And I think the Environment Agency in the UK did have a huge monitoring regime that was in place, and it's an easy regulation tool. So I appreciate all that. So as I said, on the very large agglomerations, we have to do a plan, and then on smaller agglomerations, a plan is needed where there's an environmental or health risk, and we give a very long list of the different pieces of regulation, including the Water Framework Directive, and meeting those requirements, or the Marine Strategy Directive, or the Bathing Water Directive. So there, we're giving the flexibility at EU level as to how it's interpreted. But what's happening now in the next year or so is member states are going to be transposing this text into national law. There is nothing to stop them putting in something stricter. This is what we have here is the bare minimum, that they need to respect. And again, that knock-on effect down at regional level, or how it's applied. We based this approach on its modelling. So that's kind of where we came, but where we deliberately left it more flexible than the old directive and how it was implemented was. And it might maybe a bit harder for the lawyers to make this a compliance issue going forward. But personally, if the money is spent on better understanding how the networks work, it's a better place to start than building more infrastructure. So I think that's where we're at.
Interesting point you just made there, Trudy, about the fact that this is the directive, this is the high level, but it's interpreted, and you may see additional law at the local level, and we're all representing different, with the local level, there's different countries. We're all representing the different countries, which brings together that overview of how things are being applied. And just thinking back to those, I'm just trying to think, how do we do policy and research together? We started out by going out and doing a questionnaire about what's happening. A repeat of that questionnaire that was done in a few years' time would be an interesting further development. This is just intended.
Can I just make one comment?
Yeah.
It's interesting that everything's been driven by modelling. You talked about the Environment Agency in the UK. So the water utilities spent 10 years putting spill monitors out in the UK. And at the end of that programme, the Environment Agency had an absolutely huge shock that the numbers of spills didn't comply with, or didn't match, what had been modelled. And it wasn't that all the models were plus or minus, it was all the models were minus. And there was an underestimate of spill frequency of 30%, even in the most. So it indicated that the modelling approach had a systematic bias to it, and it's whether that bias should be taken into account when we have our longer term plans, or do we move from modelling to monitoring?
Well, I don't think we're asking you.
Well, I just say, there's nothing to stop the Commission, if there was an infringement or there was an issue, or maybe member states were making a complaint that they didn't like what was happening in the receiving water bodies, for us to ask for more data. So, again, by giving a bit of flexibility in this approach doesn't mean that there isn't requirements to demonstrate that the measures are working or in place. So this 2% thresholds that we've suggested as an objective. If we weren't happy with what we saw was the progress, but I'm not a lawyer, so I'm not going to anticipate what will happen in the future. So I don't think we're saying we won't be doing monitoring isn't required. But there was nothing in the previous directive to require monitoring either. But that didn't stop a lot of monitors being put in place. So yeah.
Not sure to use the word a lot.
Yeah, well, whatever. Yeah. Anyway, that's it. Yeah, we're getting. Yeah.
Antonio, I would like to ask one question specifically for this focus on modeling rather than monitoring. I wonder, is there regulatory enforcement of what means to model and how to model? Because how can you model without measurements? And in the as Simon has hinted as well, there are in the UK at least 30% of the CSOs that are spilling under no rainfall, which is basically the forcing data that you have in the model.
Sorry, 30% more spills.
30% more spills.
But and a lot of CSOs are spilling with no rainfall.
So those processes are not encoded whatsoever in a model. So is there like a regulatory framework in which specifies what it means to model and how to model?
Yeah. No. Yeah. I can.
If you want to.
Yeah. Like the directive is what it is. So we haven't got into at the moment providing any implementing act on the specifics of a particular type of model. And again, maybe it's not needed at EU level, a harmonized approach on modeling. Maybe, so that's where it goes. But just to go back to this, we don't have just to recall, in the annex of the directive, there are objectives that must be reached in terms of pollution. And again, we're happy, as the directive is read, to say you use a model or whatever is appropriate, but if a member state itself or the Commission at some point in the future wants to know how you've reached that objective, you won't be able to do that at some point if you don't demonstrate with data. So I would hate for the message today to be that models are enough.
Yeah. Well, I will give you the word, but I have also a comment about this. And I agree with you, truly, that maybe this is something that has not to be regulated at EU level. So how to implement the model? I think that we need some kind of harmonization of some aspects, like this, as you mentioned before, this 2% or the content of the plans. But at the end, all the countries has to implement its national plans. And actually, for instance, in Spain, we are nowadays in the Wastewater Association discussing about how to provide some guidelines or help to the government of Spain to provide some guidelines about how to make these stormwater plans. Because in Spain, actually, we have a recent regulation from August 24, I guess, which is to some extent more strict than the new recast of the Wastewater Treatment Directive in terms of the agglomeration threshold. We are below 100. We are working with 1,000 people, for instance. We have a different emission-based standard. We work with something that actually some of us do not understand properly. So they are trying to do this guideline, and in this guideline, they will provide how to model. So, because I think that the different regions, the different, as Simon mentioned before, we have different national regulations. So it's really complicated to this high level state. Okay, we need a model with this and this and that. I think that maybe which is interesting to force to the members of the EU is provide some these high level guidelines and also the data. This is something that maybe right now is not so detailed, but how the different water operators has to inform to the governments in order that the governments can inform to the commission or to the. So this is a nice, interesting point, but at this point, I think that's yeah.
One more question over there, I think, and then.
Thank you. I'm Janek Laanel from Estonia. In first panel was actually talks that this water is a resource, yeah, we should share between these different countries. But if you think about our situation in our countries, that we have shared water resource between EU and non-EU country, and do you think that this modeling is actually the way to do with this problem? Because already was said that modeling needs the data for all these regions. That maybe the border areas actually need to be treated differently in this respect, in the EU level or this directive level. Just actually some comment. What is your explained of?
Is that something that?
Yeah, I can try and answer.
Actually, focus more east,
I'm flicking through the text.
No, thank you very much. Sorry.
No, it's no problem. Yeah, okay. I'll answer your question in a minute, but can I just go back on this monitoring, modeling thing? I was just checking the text. So there is an article on monitoring.
Yeah, there is.
And there is Article 2.
Yeah.
So just or point 2 of Article 21. So it's not that we're saying that there's no monitoring.
No, there is a monitoring there.
Yeah. So just I'll close that out. In terms of transboundary waters, so for Estonia as an example, and it's a Baltic nation, we have international sea conventions, including the HELCOM, which covers and which is probably a lot of the driver for HELCOM, I think, was really nutrient pollution of the sea. And when we model all of the seas now, we see that they are still suffering from that all the European seas, they're still suffering from inputs from urban wastewater. So we've listed those as requiring requirements. Where we better tackle transboundary issues between upstream and downstream. So if we're talking a riverine system, as well as when we're looking at the downstream shared waters, is under either the Water Framework Directive, or the Marine Strategy Framework Directive. So there is an ask that there's a cooperation and there's a coordination, particularly protecting those that are downstream of events that are upstream. This directive doesn't really get into a lot of detail on that, but what is expected in any licensing of any wastewater facility is that the national competent authorities, when they're looking at the discharge licenses, they should be using the combined approach, which comes from the Water Framework Directive. So to translate that into this, these requirements, whether it's a treatment plant or a combined sewer overflow or whatever else, are the minimum requirements. But what's required from whether it's the EA or another regulatory authority or national or regional authority who issues a license is that they are obliged to look at all of those inputs into that particular receiving water body, regardless of, and then make a decision on what is the appropriate level of treatment. So you may need higher levels of secondary or tertiary treatment, or get rid of a lot of stormwater overflows, and that's really what needs to be looked at really in the bigger piece if there's an issue, particularly I suppose in a riverine, more 2D situation. But the same is applied. So it's the source of the approach. So if there's impacts from wastewater treatment plants to shared seas or lakes or whatever, then that there is an issue that should be considered. Yeah, it is more difficult if there's obviously third countries that are causing problems at the moment. Yeah.
I think just to sort of wrap this one up, was that a quick point you wanted to make there?
A quick one.
Yes, please do.
I understand it's minimum standard, then it will be transported in each country.
Yeah.
And I think maybe we should focus our time on this transposition. Because we go from what are the impacts? Oh, too complicated. So we go on emission. Okay, let's monitor. Oh, too expensive, too complicated. Let's go for model. And I'm afraid that in the chain of this pragmatism, we go to progressively from the most important target to easily implementable key performance indicators, which do not reflect what we want to achieve.
Well-
This is probably along this chain of, I would say, degrading, that we should pay attention that what we ask at the end will really contribute to the main goal and not be something which is a kind of surrogate and we play with numbers.
Well-
That's my last sentence. This
Okay.
feeling is based on the French experience. We are supposed to monitor CSOs in France since '94.
Mhm.
So we have 30 years. If you investigate the national database, which is secret, one of the reasons it's secret is because the quality is poor. So if we do not make a significant progress, we will have the same final assessment in 45.
I think just to sort of wrap up, pull a few conclusions out of this particular session. Right at the beginning, I was saying that there's so many levels involved. It's policy is at many levels, starting at the EU and working down. And I think that you made a very good point, really, that it gets interpreted in different countries in different ways, which provides a lot of opportunities. It's quite. You probably discovered here that you're with a group of people who spent 5 years looking at a few very specific aspects of this. So I think what we've seen here is that translating science into policy and practice. We have got from Co-UDlabs an awful lot of detail. Simon's highlighted a policy document which we're producing, particularly on the CSOs. We've spoken a lot about CSOs. Sorry, Julia, if you feel you've been defending the directive here, but we mostly use a directive as an example of a policy and how research can work with that. I think what we've heard today gives us some food for thought, actually, for the next section, which is on the legacy. Where do we go next with Co-UDlabs? And how do we use what we've done here? But how is research generally used? And I almost wonder, actually, maybe Eleanor, it's something which I'm not quite sure if you're able to answer the question for us at the end of this as to how we take what we've done with Co-UDlabs and we make sure it gets integrated into policy going forward. But I think we've raised quite a lot of important issues here. And don't forget as well, as Thomas was explaining, all of this then goes right down to the guys who want to build something and to sell it and to address a solution. And that's another element of what we have done here. So, yeah, as I said at the beginning, policy, translating science into policy and practice, but it's also translating policy back into science that we can take forward with the future of Co-UDlabs. So I think on that point,
I think this is the new regulations aren't there at national level. I think there's a great opportunity to learn across different nations because they all have different experiences. And I don't think that breadth of experience gets reflected in national regulation because the experience national regulators tend to go for is within their own country rather than in different countries. And I think you'll see that reflected in what I would see is the technical capacity in different countries, because that grows based on the regulation that's there. And I think there's a really good opportunity just now to translate that experience and knowledge to different countries that may influence what regulation they would eventually want to adopt.
Thanks very much. I think it's time to move on to the next section.
Yeah, I think
thank you to our panel of presenters.
So thanks for speakers for this presentation and also for these discussions. I think now we can move to the last presentation or section, which is this legacy. So Joao, yours.
All right, so we're coming, I think, to the last section of today's meeting. And I have to say here that what I'm going to present is kind of a big responsibility because I'm presenting various aspects of the results of the Co-UDlabs. And perhaps in some of these aspects, I don't have the very detail about them. So I will, for sure, point to some people during my presentation to get some additional details. So basically, as we've heard in the morning, research somehow or sometimes is detached from practice. And here in the Co-UDlabs, we really put a big effort in making sure that what was developed in the science, in the research, could be transferred into practice and can be used to really improve our urban water systems. So we call it the legacy of Co-UDlabs, from science to networking to innovation and back. My name is João. I'm coming from EAVAG in Switzerland. And we'll then move forward. So one of the outputs that will last after the end of the project is really a set of publications and open data sets. Publications is somehow a normal output of a research project. What I would like to put emphasis on is really on these open data sets. And here we do have, as a result of the transnational access activities, joint research activities as well of the Co-UDlabs, a set of publications that have together with them some open data sets. Colleagues from EAVAG were looking into camera-based monitoring, advances in wastewater observation. And here we can see good correlation between, for example, turbidity observations from a camera versus a sensor. Also, colleagues from Manu Guerreiro from A Coruña, also together with the colleagues at EAVAG, produced these sewer real-time sediment depth monitoring, a temperature-based sensing to improve sediment accumulation estimation in sewers. Also resulting from research in A Coruña, we have these large-scale clogging experiments of porous asphalt. And here is my first stop. I would like to ask Alessandra if she could really provide one or two sentences about this experiment.
From Germany, and we work with experiments to analyze the hydraulic capacity and clogging, and to evaluate how under different rain intensities, how will be the clogging of the permeable asphalts. So we use also the found that all the permeable pavements have this clogging issue, and we need still to do more experiments and regulations to standardize the measurements to do in these pavements.
Thank you very much. Another example of data set is what we call the Urban Water Observatory data set. This is also a research effort at EAVAG, and then basically it's a result of a few years of monitoring a small village in Switzerland, Fedaltorf. And then we provide data sets on water level, flow monitoring in different parts of the village. And then the question here, so what can we do now with these data sets, right? And then this is becoming open. Everyone can use them, and everyone can really further develop methods and do whatever, or more or less whatever they want to do with these data sets. Something that we're also focused on of Co-UDlabs, and hopefully will continue after the project, is really this development of sensors. And here, again, three examples. One called Pollution Keeper is basically a non-contact wastewater quality monitoring sensor. The development was included in the work package 6 results, directly involving companies, in this case, Fotrak. Another monitoring or another sensor to look into ammonium was developed with GoSeas, another company. And the first attempts to really monitor E. coli. But here was really, this is science, this is research. The first results were not really very good. So again, further research to be continued here to make these things to work. And here just to highlight that some of these sensors are really market ready. Some of these companies, I have a close contact, for example, with Fotrak. They are really in the market. They're really trying to sell these services and benefiting from the access to the facilities made available on the Co-UDlabs. Moving on, Co-UDlabs was also very much about networking. And here, as a group of research institutes, we really aimed to involve industrial partners. 3 examples here from the US, Poland, and Iran. And during the 4 years of the project, we were able also to invite and collaborate with colleagues, researchers from Poland and Prague. So again, expanding the network beyond the research partners directly involved in the Co-UDlabs. And hopefully, these research partners have also had easy access to the developments of the project and now can really further their own research on the topics of urban water management. Another way that Co-UDlabs used to really achieve or engage with more people was really to prepare webinars to describe and to discuss the development of the sensors, to present and discuss the data sets developed and also the data validation or the quality of this data, for example. Early stage research activities. So there was a European Junior Scientist workshop on sewer monitoring in 2022. There'll be another one this year. It will be 2025. I think there's a typo there.
There were 2.
There were 2. Okay, so there were 2. There's another one. So then we foster really this interaction with young researchers, webinars open to everyone, including industry training and also online training. And as an example, the 6-part course on pressurized systems. I mentioned already these data sets or the development of these data sets. And as part of, I think, all the project would also focus on work package 2, for example. There have been some developments on trying to make data or harmonizing the data, making the data accessible in a good quality and easy way. And in this sense, this international working group on data and models have been is somehow involved in trying to find a way that people could start collecting data in a standardized way, in a uniform way. And then the question is, why open data? So then we are not talking about these machine learning or data-driven models, machine learning models, and they do require large data sets. And one of the direct applications of collecting data or fostering the collection of data with good quality in a standard, in a defined form, is that then these data sets can be used by whoever would like to train these data-driven models. We have a few contributions here. Belling dataset, the UVO dataset that I already mentioned, a flood dataset that I've been working with, spectrometer data, the Groove dataset that Jean-Luc has been collecting and working. Do you want to say something, Jean-Luc?
Yeah. Stellas is part of the transnational access indoor graphs with German partners, and IKT is one of these partners. And we have built 2 green roof pilots, and we are monitoring their hydrological behavior over an entire full year. It will be finished after the end of the Co-UDlabs project. We will have a dataset with a 1-minute timestamp, and it will be shared as a public outcome of the project at the end.
Good, thank you. And these activities on data collection, data sharing, data organization, basically will continue beyond, directly beyond the Co-UDlabs project on these, with this Inscribe project that my colleague Jörg Hickermann and I are really conducting at EAVAG. As an example, there's more things lined up for sure. And here, other community actions. Co-UDlabs really helped creating a new working group within the Joint Committee on Urban Drainage. Actually 2, the UDrain directly connected to Co-UDlabs. And this slide is about exactly this group, and I would like to ask James to drop a few words on these.
Do that for you. You're looking quite lonely up here.
Yeah.
Hi everyone. So my name's James Shuckman from the University of Sheffield. I've been looking after a number of transnational access projects at Sheffield. Prior to that, I've been doing quite a lot of work using experimental facilities, but I would say that wasn't really so much collaboration between different groups. And during Co-UDlabs, I think we've had a real opportunity to kind of work with other people that have been using urban drainage facilities and learn from each other. And that came about from, quite informal sort of meetings. So I first met the people from IKT. They came to visit us in Sheffield. See, there's 3 of them here. They turn up for everything. So they came to visit me when I did a dissemination event for one of my projects. I met Jose at a conference. And I think we've discovered the value of working together and learning from each other, learning best practice. And I think we've learned that these experimental facilities are quite precious, and you do need to keep using them. So we've kind of formed this sort of UDrain group to try and carry on some of that cross-group learning and look for further opportunities, and also expand the opportunities to other operators of large urban drainage facilities. So one of the first actions that we've done is try and set up this UDrain Atlas, which is really big, a big list of different unique research facilities around the world looking at urban drainage, and try and carry on some of the cross-community visits to learn from each other and look for opportunities in the future about how we can work together and learn from each other. So I think that's very new. It's in the process of being set up. So we're going to have some more meetings at conferences in the future. I think that's all I need to say.
Perfect. Thank you, James. So I stay alone for a few more minutes. Thank you very much, James. Another new group on water quality also was created and has been chaired by a colleague at EAVAG, Lena Mutzner, and really look into developing and benchmarking AI-enhanced resource-effective water quality monitoring technologies. And this is, again, linking the monitoring and the data sets and how do we monitor, how do we best monitor, how do we collect the data, how do we share the data. So, again, very well aligned with the Co-UDlabs project goals. And then we come here to the future collaboration, right? So, open in future calls. There's a Water for All call, European Water Research Funding, Water and Health, lined up for this year. We somehow should start discussing about these and other opportunities. And of course, we are very welcome to know and receive information about incoming calls on this topic. And the question is our legacy, right? And then how can we bring all these very interesting and valuable, I think, for both researchers and industry, results to be used and beyond the project. We plan to somehow summarize all this information that I've presented, and I did not present everything, I have to say here, and create somehow a document or a platform or a website, something that could be ideally interactive, that we start with research or practice questions and show how Co-UDlabs really can help or does help answering these specific questions. This gives added value to the Co-UDlabs outcomes, so then people can access these, can get to know the outcomes, and then hopefully also start fostering some discussion that can continue after the project. As 2 examples, one of the questions could be how to evaluate uncertainties in urban drainage monitoring and data sets. And these questions could be supported, answered, or partly answered with the urban drainage metrology tool that has been developed by the colleagues at INSA under the coordination with Jean-Luc, for example. And then another example is how to improve the measurement monitoring of ammonium in sewer systems. And again, here we can list the developments or the data sets that have been produced, the GO-C sensor test in Co-UDlabs, compare the data collected by a new sensor with benchmark data collected during Co-UDlabs, and so on. And then for example, each activity, we can create an online matrix, this aspect of being interactive and people can really learn and find answers to their questions. Something like these, where we could list the several questions or the questions that could be answered from the outcomes and results of the Co-UDlabs, with a focus on research, for example, in red, and practice in blue, and then people could pick the dots and really be directed to the links where they could find more information. And very close to close this short presentation. So our legacy are discoveries, innovation, and education. So some science impact on publications and open data. It's becoming available to everyone. Innovation, so then market-ready technologies, new sensors, also information about attempts that do not work as planned at the beginning, so further work is required. Networking, so expanding global collaborations. So we brought together new partners that were not at the beginning in the project. The UDrained working group is also an example of trying to bring people around these topics covered in the project. The community, how do we transfer the knowledge here with the training courses, online courses, industry workshops, the open research data sets, data harmonization, and so on.
Thanks, Joe. So thanks to everybody for attending to this and interacting this final info day of our project. Just a few words to conclude in this talking about this legacy. When we define or we try to think about this, we have like 2 aspects. One, from my point of view, one is this how to reuse all the information, not just the data, because at the end we were discussing recently that we have several data sets. These are results of the project, but then we want that people can reuse this information and the tools. So because of that, we move to this matrix that you present, or these frequently asked questions that you can answer. If I want to do that, how I can proceed. So this is something that we thought about recently. And the other point, as Elena commented is related with the funding. I really like the presentation of Thomas in the roundtable, because it's a really nice example of the huge complex ecosystem of stakeholders that we have in a particular case, and how the work of a transnational access is not just providing the lab, is promote the creation of the networking activities with all the stakeholders, even make some training to these stakeholders, to the operators, to the council workers, and so on. And then bring in this pool to some people that can provide solutions, bring innovation with different levels, companies, academia, and test these solutions, improving the services of our network with these joint research activities. So from my point of view, it's some kind of nice example of what this transnational access project can provide to the facility. For sure, we have maybe more focus on the technicalities, or in the lab, or in the governance, or wherever. But this could be a way to bring this innovation to the urban drainage ecosystem. And the problem is how to get the funding. That is something that we have to look for at different levels, from the local and the municipal and the regional governments, to solve problems that they want to solve. So I think that we can think in consolidated as research infrastructures without the support, to some extent, that we have with these Infraia projects. And then moving to another new topics, try to provide more transnational access, because we really like it, although it's really complicated and really complex. But I think that all of us, we are here because of most of us are here because of this thing, and we like it. So we have to look for and try to continue, and this is our, let's say, midterm ambition, and we will continue on that. So it was a pleasure being here, having this day. I would like to thank to Fundación Galicia Europa as well, to all the contributors of this session, and all the partners and all the community around Co-UDlabs. So thanks.